Thanks for playing Sticks, Stones, and Bones. In this video, I'll walk you through the purpose of the game. First, in terms of how your own mental processes worked as you were playing each level of the game. And then, after that, I'll introduce this game as an analogy for children who are in the process of learning a new language and are also learning basic math concepts at the exact same time. Now, this can look different for children in different countries, but here in the US, these children would be called English learners, or ELs, since they don't speak English at home, but almost all schools teach everything in English. So first up, your own mental processes. Did you notice while you were playing the game that every level took longer and longer? If you didn't, feel free to go back and play the game and see if that statement checks out. You may already have an intuitive feeling about why it took you longer to solve every new level of the game. In cognitive science, there's a theory called cognitive load theory, which tries to explain this intuitive feeling that you probably have by breaking it down into systematic parts. Now, before I delve further into this theory, let me give you an example of what these different parts look like. Okay, so let's start with the parts in light blue. These are times when your brain is trying to put in more effort or energy to learn or understand something. So as an example, let's say you are trying to memorize this long string of random numbers in front of you. Could you do it? Absolutely. You just played the game. You're a rock star. But that doesn't mean your brain doesn't have to expend energy to actually learn this random set of numbers. Now, what if I were to make this a little harder and put in a time limit? Say I give you 10 or 15 seconds. Again, would you be able to do it? Probably, but this means your brain needs to speed up the rate at which it's learning. Otherwise, you might not be able to memorize this entire set of numbers. The part in dark blue, however, is the opposite. It's when your brain doesn't need to put in as much energy because it already has patterns and systems to make sense of the information that you're trying to learn or understand. So as an example, let's say you took a second to find patterns in these numbers. You might notice that the number starts and ends with 1, and every other number is 1. Right? And then you might realize that the other numbers in between, 8, 6, 7, 5, 3, 0, 9, maybe they're not so random because you might have heard a song like this. Now that your brain has some tips and tricks to memorize these numbers in the form of a song and some patterns, that means your brain doesn't have to put in as much effort to remember this long string of numbers, which also then means you will be able to learn this information a lot quicker. Just like the example, cognitive load theory tells us 3 things. When you're playing a game or learning new stuff, your brain needs to do 3 things. First, it needs to make sense of new information coming in so you can learn and understand. That is your intrinsic cognitive load. Then it needs to manage your distractions so you can continue to learn. That is your extraneous cognitive load. Your brain also needs to connect the new information coming in to information that already exists. That is your germane cognitive load. Now, all of these things take energy, which is why learning is just very effortful. Unlike the other two, though, germane cognitive load is less effortful or takes less energy in total. So if the first 2 things are like cooking from scratch, then germane cognitive load might be something like cooking with leftovers or, I don't know, heating up a frozen dinner. Okay, so let's go back to the game. Do you remember in the first level where all you had to do was remember one rule and then just apply it from stones to sticks? Well, that's a one-step process. In the next level, you had to do two things. You had to remember information from the previous level, but also process new information. So that is a two-step process. In the later levels, you had to do three things. First, you had to remember old information. Then you had to process new information while also incorporating old information. And then third, you had to manage your distractors and pressures. Managing your distractors could look something like processing your stones first and then processing your bones, or it could be just remembering that a timer was ticking down and you still had to just focus and concentrate on the problem. That means this was a three-step process. I hope this gave you a little bit of insight into your own mental processes as you were playing the game and why the later levels felt a little bit harder or maybe a little bit more effortful. This game is also an analogy for how English learners learn math. Just as a reminder, English learners are children who are learning English, but also learning math in English at the same time. Did that analogy about English learners learning math in English make sense to you? If you recall the stress or cognitive overload that you felt in the later levels of the game, that is probably how an English learner feels all the time at school. Except their cognitive overload is probably more likely to lead to poor performance because unlike adults, most things they learn in school are new to them. This also means they would have fewer coping strategies. If any of this piqued your interest, please feel free to check out our interactive poster. The link is included here. The main research question that we explored in this study was whether speaking a home language other than English affected the child's math performance. We compared English speakers and English language learners on variables such as English proficiency, math preference, whether or not they were bullied, their gender, and the quality of their math teacher's teaching. If you'd like to learn more about what we found in our research, please feel free to check out our interactive poster.